This week we're going to be looking at electromagnetic induction, and we're going to finally be understanding how we can take motion and use motion to generate electricity. If you remember back at the beginning of the semester when we were looking at heat engines, and I kept saying, oh, it's so useful where we can use heat in order to move a piston up and down in our engine. And I said it's so useful because we can, when that piston moves up and down, we can either use that motion to generate useful motion, like have the piston move up and down and have that turn a crankshaft, which turns the wheels on our car and drives our car forward. Or I said that we can use the motion of the piston moving up and down, and we can use that to generate electricity. And then I said we have to wait till the end of the semester before we understand how motion can generate electricity. And finally, today we're going to start to understand that, and that's via the process called electromagnetic induction. So let's start with some history. So this is from Michael Faraday, a scientist from a long time ago from the 1800s. And he noticed that when he had a loop of wire or a coil of wire here, so this is just a coil. This machine here, a galvanometer, is just measuring current. It does not supply any current or power or anything like that. It's just measuring it. And he noticed that when he took a magnet and moved the magnet through this loop of wire, he would measure a current. That's what he noticed. So pulling a magnet through a coil creates a current. That's one of his discoveries. He also noticed that if he left the magnet there and the magnet was not moving, so the magnet was just stationary, his current reading would be 0. There's no current flowing through the coil of wire when the magnet is stationary. When you move the magnet, then you do have current flowing. When you don't move the magnet, you have no current flowing. He also noticed that when he set up two circuits next to each other, so this circuit has a battery, has a resistor, and then it has this loop of wire here and a switch. This circuit over here has a loop of wire that's kind of parallel to this one, but no battery at all. No source of current, no source of potential difference in this circuit over here. And what he noticed was when he closed the switch on this first circuit and current began to flow through this first circuit, there would temporarily be current flowing through the second one. But then that current would go away. Then when he opened the switch, current would flow through here again in the opposite direction, temporarily. Then when he closed the switch, he would get a little bit of current for a little while. Then when he opened the switch, he would get a little bit of current for a little while. So opening and then closing the switch in this circuit number 1 created a current in circuit number 2. So believe it or not, these two things are related. And you should actually recognize that these two things are related because we know that here we're dealing with a magnetic field, and here we're talking about a current, and last week we learned that a current creates a magnetic field. So these are two examples of the same type of phenomenon that's happening. So think about this, press pause, read through this, try to think about it, and choose an answer that you think best describes the phenomenon we were just looking at. In both cases, we were looking at a changing magnetic field, and that was the thing that was generating the current. So let's look at that a little more carefully. This is Faraday's law, and Faraday's law has to do with the phenomenon we're talking about today, which is called electromagnetic induction. So Faraday's law says that a changing magnetic flux, we'll talk about flux, we'll review what flux means, but a changing magnetic flux through a coil of wire induces a current. So first let's just look at this word induces, or this word induction, and let's really understand what that word means. So induce means that you create something, or you bring something into existence, or you make something happen that wouldn't have happened ordinarily on its own. So what happens is we're going to induce a current. There wouldn't be a current on its own, but because we have a changing magnetic flux through a coil of wire, there will be a current that is induced. And that's an example of electromagnetic induction. So in this example, when we move the magnet through this coil, as you move the magnet closer and closer and closer to this loop of wire, the magnetic field strength gets bigger and bigger and bigger in that wire, in that loop. So the flux through that loop is increasing and increasing. So that represents a changing flux because the field strength is getting bigger and bigger and bigger, and that induces a current. In this case, let's say when the switch is open, there's no current flowing through circuit 1, which means there's no magnetic field passing through these coils here. Now when you close the circuit, there is a current, so now there is a magnetic field due to that current, and that's a change. That's a changing magnetic flux because before there was no magnetic field, and now I close the switch, and now there is a magnetic field, and that represents a change in the magnetic field passing through this loop. And we can calculate that as a change in flux, and that's going to induce a current in circuit 2.